Good morning, mathematicians. We are looking at the Tuesday column for week 22, and we are beginning with thinking about multiple forms of decimals. So initially, we are given this. Boys and girls, I know that three places after the decimal point where the 7 is sitting is the thousandths place. So I would read this as 537 thousandths, which also is how I would create it as a fraction. I'm going to put 537 on top. I'm going to put 1,000 down below because that is how it compares to 1,000. I have 537 out of 1,000. That is literally what I see as I read this number. I went ahead and written down the word form, which is just what we said, 0 and 537 thousandths. And I'll put an S on the end because certainly it is plural. I should have 0 and 537 thousandths. Okay, boys and girls, now we are thinking about expanded form. Expanded form is adding this by its values. It has 5/10 plus 300 plus 7,000ths. That is it in expanded form. Now, my students are also working on expanded form with multiplication, so I snuck that in here. And boys and girls, what we've talked about is separating out the digits, five, three, seven, almost like an accordion. We stretch those out and then we multiply them by the value that they're sitting in. 5 times 1 over 10, 3 times 1 over 100, 7 times 1 over 1,000, and we're going to add those together. That's expanded form with multiplication. So we snuck in an extra expanded form here, okay? Now, boys and girls, we are thinking about this. Big Bendy Tower in London is 96 and 32 hundredths meters tall. The city mayor wants to know the tower's height, but only to the nearest tenth. What measurement should be reported? Well, when I look at this right now, it has a tenth place and a hundredth place, but I need to report it only to the nearest tenth. So I ask myself, if the hundredth place digit is a 2, does that mean I'm closer to 4/10 or closer to 3/10? This rounds down because certainly 2 is not 5 or more. It is not closer to 4/10. So my answer should be 96 and 3/10. And remember that our answer should be in meters. Since that unit is given in my words, I'm going to make sure to report it in that unit for my answer. Now I am told to shade 722 thousandths below and write it as a decimal. I started with writing it as a decimal first because if this digit right here is going to in the thousandths place, since that is the place I named and claimed, I know that this 2 has to sit in the thousandths, this 2 has to sit in the hundredths, this 7 has to sit in the tenths. And that also helps me see exactly how I'm going to highlight, model, shade this. This 7 means that I'm going to highlight 7 columns because each column represents 1/10, one of the 10 columns that it takes to build a whole. This 2 represents the hundredths. So I'm going to highlight 2 singles because each of those singles represents one of the 100 that it takes to build a whole. And lastly, I have a 2 in the thousandth place. I'm going to think about this one single right here on the end. If I divided this into 10 parts, I have 2 of them. That's why I just extended my shading just a smidge into that third single in this column, and that demonstrates my 2,000. All right, boys and girls, now we really get to the 2 questions I think out of this entire week that are maybe the very best questions that take the most stick-to-itness. Certainly, we can see my answers are written right here. Don't just write down those answers, boys and girls. Instead, really challenge yourself to think, how do I calculate irregular volume? The way that I calculate irregular volume is to calculate the volume of this prism A, calculate the volume of this prism B, then I'll add those together. Boys and girls, I would look for the length, the width, the height of this prism A. These are actually labeled for me. So my length is 5, my width is 6, my height is 2. I'm going to go ahead and show you where I've drawn this out to demonstrate this. I'm going to move this so that hopefully you can see it a little bit better. There we go. I have 5 and 6 and 2. I have written out my formula. Volume equals length times width times height. Volume equals 5 times 6 times 2. When I carry that out for prism A, I get a volume of 60 centimeters cubed. Very important to claim that we're measuring this in cubes, right? Now I'm going to look back at prism B. For prism B, I have to figure out what is the length. Well, that one is actually listed. That's 2. What is the width? Well, the width is unchanged. From here, I saw it was 6. So here, it will also be 6. My width equals 6. Now I have to figure out the height. Now, that was not labeled for me, but I could figure it out by context. This height was 6. Notice this much of that height was used up in prism A. So I know that this height is 4 because 4 plus 2 gives me that overall 6. That is how I arrived at prism B being length of 2, width of 6, height of 4. You can see on my post-it note, volume equals length times width times height. Volume equals 2 times 6 times 4. Volume equals 48 centimeters cubed. Now, what is very important when you do a regular volume? I calculate the prism of this, the prism of this, or the volume of those prisms, I should say, and then I'm going to add those together to get my overall volume. I have one more question that I am looking at, and this one again really takes some stick to itness. I have 2 prisms that I am calculating the volume of. I'm going to use the same strategy. I separate the volumes. Here I have the length of 10, the width of 2. I don't have a height measurement that's listed, but similar to our last problem, I can figure it out because the overall height of this entire shape, both prisms, is 11. This prism is going to use up 9 of those meters, so this one is going to have a height of 2. Therefore, I can see with this prism on the bottom, just like I said, I have a length of 10, I have a width of 2, I have a height of 2. Volume equals length times width times height. Volume equals 10 times 2 times 2. Volume equals 40. Now I'm going to be specific. Those are meters, and of course, they're cubed. Now let's take a look at this top box, and it's bigger. I can look and see the length of this one is not listed here, but it is listed on a congruent edge. So the length of this will be 12. The width will be 4, and that is labeled, and the height is 9. Let's write those down. Volume equals length times width times height. Volume equals 12 times 4 times 9. Volume equals 48 times 9. And again, you'll have to use whatever strategy you want to calculate that. But just for that one large prism, my volume is 432 meters cubed. Similar to my last problem, this was prism A, this is prism B. I have to add those volumes together to get 472 meters cubed as my overall volume. And that finishes out our Tuesday column.